integrating with trigonometric identities, first you need to identify which trigonometric identity you should use for the problem. In this case, sine of x is 1 over cosecant x. So when you multiply, you will get cosecant square of 2x to the third power. And when you have the cosecant square of 2x to the third power, you can find it in the catalog. And in here, we will use also the trigonometric identity, which will get 9x squared cosecant of 2x. Is also in the catalog. The correct way to solve this problem is using the identity of cosecant, which is 1 over sine of 2x to the third power, because you will get sine square of 2x to the third power, and it will be a much longer process. When having integrals of trigonometric functions, it is easy to use the substitution method. First, we identify the trigonometric function with the highest power, in this case 7, and then that will be our u, and our du will be the one that is already there in derivative. So we only add up a power and we multiply times what we balance, so we have an easy answer. Other options are not appropriate because if we use identities or even or odd methods, then the procedure will not only be very long but impossible to simplify.
When dealing with even powers in trigonometric functions, you have to use the double angle identity. So here you have to use 1/2 1 minus cosine of 2 times 3x. You solve it and then you get the answer. The incorrect way to do it is by using the Pythagorean identity, which is 1 minus cosine squared of 3x. If you use the Pythagorean identities, you would end up having to use them all the time and you will never finish your problem.
When having integrals of trigonometric functions with odd powers such as 3, we must use the Pythagorean identities. So first, we must separate the function. For example, one function of sin and sin to the 10th power, and then we apply or we substitute the function. So then we make FOIL, and as we see, we have two separated integrals. In one, we can solve it by catalog, which is the first answer, and in the second one, we solve by substitution. How this problem could be incorrect or why other methods are not useful, since we have not a power, but when we separate, we find out that we have a sin to the second power and we want to use even identities. It is not possible because at the end, when you keep solving and keep multiplying, we will have sin as the first one, which is solved by the catalog, but here we cannot use substitution because argument of cosine it cannot be changed, as 8x cannot be changed by multiplying etc. to 4x, so it is impossible to change the argument. That's why we have to use odd identities.